Linear programming in any ambit is really useful as a decision-making tool. Our group has come up with a new way of using optimization. Linear programming is actually used in politics.
And if politics are concerned, because some people committed them to vote for you, how can we actually convince those votes? Simple. Campaigning. We thought that the most important part is the selection of the advertising media.
On the selection of advertising media, it is precise to say that as a political party, the goal is to have the highest audience watching our spots, based on the premise that the higher the audience, the higher the potential voters. Our political party, JCL, is ready to hit the upcoming elections in Nevada. Our desire is to get as many audience as possible on our spots. The first step is to select the media according to our opinion and taste. For television, we chose Antena 3 and Telecinco. On the radio, Cope, Onda Cero, and Cadena C. And finally, advertising mail shots. The second step was to collect information based on real statistics, such as voters, based on the population of Navarra, and these are some of the bases where we found the information. The third step was to organize the data and fill in the Excel with the audience, the cost of the commercial, and the limit values.
Once we have collected all the data, it is time to start with the mathematical model, identifying the objective function and the set constraints. The objective function that we have to maximize is for by the sum of each variable with its corresponding cost. Without forgetting that our variables stand for x1 to Antena 3, x2 to Telecinco, x3 to Radio Cope, x4 to Radio Onda Cero, x5 to Mail Shots or Bufoneo, and x6 to Radio Cadena C. Afterwards, the constraints subjected to all partakers. These conditions depend on every media's policies, constraining the number of adverts we can release. That is why, for example, on Antena 3, we can advertise more than in Telecinco. But those are external constraints. We must not forget about the internal ones. I refer to the capital budget, which in our case is 1 million. This means how much money do we have? That is to say, how much money can we spend?
When we complete the previous steps, it's time for Excel, which in combination with the analysis tool solver will give us the optimum values for the maximization of the audience. In relation with the problem characteristics, there is nothing new. We just state our goal and the variables meaning related to the case. On coefficients, we will write our objective function to maximize and the restrictions related to the media and budget. The most important thing is the relation between the restrictions and its limit values. All these restrictions have to be less or equal to, as there is a finite budget and a maximum commercials permitted by law. The formulas part, we have to be careful with the cell selection. We have to leave some cells for the optimal values indicating which result correspond to each variable. Here, we will introduce the summa producto formula, being the matrix 1 always the same, except for the audience cell, where matrix 2 is the objective function cost without the variables seen before. When we fulfill the three parts, we start the solver. In the parameters tab, we will enter our restrictions with the relation to the limit values. We have to check that solver uses non-negativity constraints as audience cannot be negative, that the solutions are integers, and that Excel will use simplest method as it is a linear programming case. After solver has completed several computations, it will show us the Excel formula cells filled with the optimal values of commercials, the capital use, and the audience maximization. Finally, if we sum up the three previous parts, our Excel file will have a similar look to this one.
The results previously obtained show us that the best solution that fits all the constraints is 15 commercials for Antena 3, 10 commercials for Telecinco, 21 spots in Cope, 11 spots on Onda Cero, 0 in Mail Shots, and 18 spots at Cadena C. This combination of inputs gives us the higher audience, satisfying all the constraints. Therefore, according to Solver, if we want to maximize our party total audience, the best options are Antena 3, Telecinco, Cope, and Cadena C, because they all have affordable prices for high audience indexes. Besides, the Mail Shot option is left behind, due to the contrary, an very high audience index with a high price. Finally, Onda Cero is on the middle, with a median audience and not very costly. Then, the specific solution would be more than $70 million potential reached by our campaign. However, this is an approximate audience, calculated by total visualizations, not people. On the first scenario, we saw that the total use was around 995,000 euros. What would happen if the party was to avoid misappropriation? In this case, the capital budget would be fully used, changing one of our restrictions.
Once we are on our Excel file, we have to change the restriction 7 that has to do with the capital budget. Here we have to change the relation that has to be equal to 1 million. Now we go for Solver and we select the cell that has to do with the capital budget. We select equal, accept, we check that it's correct, and we go for the solution.
Comparing these two situations, we can see that almost all spots have generally decreased, except for the Mail Shots, which have increased by 1 after adjusting the budget. Surprisingly, our audience, which we wanted to maximize, has decreased when increasing the budget. In linear programming, we can see that using more money doesn't involve getting the better result. Our best result was reaching the first scenario with the largest audience when using less money. Basically, changing the less or equal to by equal to reduces the feasible results. Linear programming in Excel gives us detailed and rapid results. They are therefore very useful when it comes to accurate decision making. Thank you and hope you enjoyed our case as much as we did.